Okay, so here we are on problem number 4. We're trying to write the equation of the tangent line to this function, x squared plus xy minus y squared equals 1, when x equals 1. Whenever we're writing an equation of a tangent line, we need an x coordinate and a y coordinate. And because they didn't give us the y coordinate here, we actually need to find the y coordinate. So to do that, we're going to plug in 1 everywhere I see an x. So that's going to give me 1 plus y minus y squared equals 1. And then, to solve these, we always set them equal to 0 and try to factor. So let's move, this 1 over, subtract it on both sides. And basically what you're going to end up with is y minus y squared equals 0. And you can factor that to be y, 1 minus y equals 0. So you get two solutions, y equals 0, y equals 1, which means there's 2 points we're talking about here. We're talking about the points 1, 0 and 1, 1. Right? Because there's 2 y values when I plug in the x. The next thing we need to do is now that I have the points, I need to find the slope. So to find the slope, I need to take the derivative, right? So the derivative is going to be 2x plus, we've taken the derivative of this product thing so many times now, we should be getting good at it, y. This is product rule, right? Derivative of the first is x is 1 times y, plus derivative of y is y prime times x minus 2y y prime equals 0, right? We want to know what the slope is. We want to know what that yellow thing is. So let's, do our process. Get all the y primes on one side, everything else on the other. So it's going to be y prime x minus 2y y prime equals negative 2x minus y. We're going to factor out that y prime, and we'll get y prime times x minus 2y equals negative 2x minus y. And we'll divide both sides, and we'll get y prime equals negative 2x minus y over x minus 2y. All right, that is our slope function, right? And so now I am trying to write the equation of a line in the form y minus y1 equals m x minus x1. I still haven't found my slope because I need to plug in the points that I got to find the slope, right? So let's do that over here. Y prime at 1, 0 is when I plug in 1 and 0. If I plug in 1 and 0 over here, I get negative 2 minus 0 over 1 minus 0, which is going to be negative 2. And if I plug in 1, 1, then I get negative 2 minus 1, which is negative 3, over 1 minus 2, which is negative 1. So that's going to be 3. Right? So 2 lines. The first one is y minus 0 equals the slope when it was 1, 0 was negative 2 x minus 1. Okay, that's one tangent line. And the other one is, so that was for the point, 1, 0. And then at the point 1, 1, our equation is y minus 1 equals 3 x minus 1. Right? And that's the lines. That's the equations. All right, keep on going. Find the points at which the graph of that thing has a vertical tangent line. Pretend the picture isn't there until afterwards. So we need to find a vertical tangent line. So again, we need to find the slope, and then vertical tangent lines have undefined slope, right? So we need to take the derivative and find out, well, where is it undefined? So we just start with the derivative. 8x plus 2y y prime minus 8 plus 4 y prime plus 4y prime plus 0 equals 0. All right, get all the y primes together. It's going to be 2y y prime minus plus 4y prime equals 8 minus 8x. Factor out the y prime. right? You want to get all these y primes together, factor them out. So it'll be 2y plus 4, 8 minus 8x. So y prime is going to equal 8 minus 8x over 2y plus 4. And so we have this. This is our slope function. And remember, we want to know when is the slope undefined? Well, it's undefined when the denominator equals 0. Well, what value makes the denominator equal 0? When does 2y plus 4 equal 0? That's when y equals negative 2. So no matter what, when y is negative 2, my function will be undefined. Well, let's go and find the points that is, right? So let's plug in negative 2 and figure out, well, what's the x value, right? So we're just going to plug in negative 2 up here. It's going to give us 4, plugging into original, negative 8, and what we'll get is 4x squared minus 8x equals 0, which is 4x times x minus 2. So when x is 0 and x is 2, right? So we have, right, we're trying to find points. So the points are 0, negative 2, and 2, negative 2, right? So let's now look at our graph now that we've done all that. 0, negative 2 is here. 2, negative 2 is here. Look what happens if you draw those tangent lines, right? They are straight up and down on that function, right? Undefined slopes, right? Straight up and down. Right, and so for problem number 6, we're trying to find horizontal tangent lines, right? Lines that go straight across have 0 slope, right? Horizontal tangent lines have 0 slope. So there's our function. Let's take the derivative. 2x plus derivative of x is 1 times y plus the derivative of y is y prime times x plus 2y dy dx equals 0. Just so you know, if you graph that x squared plus xy plus y squared equals 6, you get this ellipsoid thing over here on the right. Oh, look at that. I've been messing up the notation here. This is y prime. Okay, so now that we have the derivative, let's try to solve for y prime. Let's take a couple steps at once, right? Y prime is we're going to have that, and we're going to end up factoring it out here, right? And then on the other side, we're going to have y minus 2x, negative y minus 2x, right? And then y prime will be negative y minus 2x over x plus 2y. We want to know when is this equal to 0, right? So we set it equal to 0. And we get negative y minus 2x over x plus 2y. And again, the denominator doesn't matter. So all we need to know is when does the numerator equal 0. So that's going to be when negative y minus 2x equals 0, which notice that there's two variables you're not going to be able to solve, but you can get it to say when y equals 2x, right? It'll be 0 when y equals 2x. So basically when the y coordinate is twice as big as the x coordinate, this will happen. Which that doesn't quite give us enough information, but what you can do, just like before when we plugged it back in, I can take this and I can plug it back into my original function. So y is 2x, so I have x squared plus x times 2x plus 2x squared. Right? Simplify this, you're going to get x squared plus 2x squared plus 4x squared equals 6. That's going to give us 7x squared equals 6. So x equals 6/7 the square root plus or minus the square root of 6 over 7. that's what x equals, and if x equals that, then y simply equals 2 times that, right, because of this equation over here. So our points would be square root of 6/7 to square root of 6/7, and the other one will be negative square root of 6/7 and negative 2 square root of 6/7, right? And then if you look at these points over here, what is the square root of 6/7? Let's figure it out. The square root 6/7 is about 0.9. So I'm going up this way about 0.9, a little less than 1 here. Okay, so I did make a mistake up there. Way back here we had y equals negative 2x, right? And I plugged in 2x, not negative 2x. I really need to change this to a negative 2x, which you know, changes this to negative 2x squared, which means that instead of 7 here, we actually have a 2, 3. And then when I do this, I will have plus or minus the square root of 2, right? 6 divided by 3 is 2, and then you take the square root. And so our two answers are the square root of 2, 2 square root of 2, and negative square root of 2, negative 2 square root of 2. And the reason I caught that is, like, looking at the point here, what I was trying to do before is obviously there's no horizontal tangent line there, right? Like, where visually are the horizontal tangent lines? Well, they're here and down here, and so that's what I should be getting. So let's try this now in our calculator. What do I get if I do square root of 2? That's about 1.4, right? So if I go 1.4, then I'm still messing this up. This one's negative and this one's positive because it's negative 2x, right? Then I should go down negative 2.2, right? Down negative 2.2. And then you can see there, at that point, this is this point there, there's a horizontal tangent line. And then if I go left 1.4 and up 2 times 1.4, then I have a horizontal tangent line right there, which is this point. All right, so that's how that one goes. The rest of these ones are kind of review of how to take derivatives and then how to check your answer with the graphing calculator. So let's do that real quick. Like, how do I do it on a graphing calculator? Remember, you're just meant to check your answer to see if you're doing it correctly. So find the derivative of each function. We're going to press math and then 8. Okay, so math. And then if you can scroll down to 8, but like if you look at what 8 is, it says end derivative, right? So you can either press the button 8 or scroll down. It's easier if you press 8. And then it's, you know, what's the derivative with respect to x of what function? Well, I want cosine negative 4x. Where do I want to evaluate it, right? At that point, it's like, where do I want to evaluate it? Well, for all of these, we're using when x is 3, so I put a 3 right there. And then I'd hit go ahead and do it, and I get 2.462, right? And so I'd look for that 2.146, which is this one right here, right? But I also want to, part of this is taking it by hand, right? So the derivative of cosine negative 4x is going to be sine, negative sine, negative sine, negative 4x times negative 4, which basically just ends up being 4 sine 4x. And what I should realize is that if on my calculator I do 4 sine 4 times 3, right? Or if I plug in 3, it should get the same answer. Sorry, this is negative up here. I should get the same answer as I did before, right? So I'm checking that, hey, I did do this derivative correctly because my calculator showed me that it was, right? So let's just go through some of these other ones. G prime of x here is going to be 3 secant squared times 4x times 4, which simplifies to 12 secant squared times 4x. This one, derivative of secant is secant tangent times the derivative of the inside. Derivative of the inside is 3x squared. And let's just leave that one like that. This one's different, right? This one's saying secant x cubed, right? So the derivative of that is going to be 3. Inside stays the same. And then the derivative of the inside is going to be secant x tangent x. Right, so that's that. And then, you want to check your values by using the calculator too. This one, y prime, the derivative of cosecant, very similar to secant, right, but negative. If secant went to secant tangent, then cosecant goes to negative cosecant cotangent times the derivative of the inside, which is 3. So, the best answer is negative 3 cosecant cotangent, like that. Derivative of cotangent, if we got tangent, we can go cotangent. Tangent with secant squared. Cotangent is going to be negative cosecant squared. Inside stays the same, times the derivative of the inside. So best answer, like that. This one is tan x squared. Again, the square is on the x, not on the tangent. So this is just going to be derivative of tangent is secant squared. Inside stays the same, times the derivative of the inside. That's it for that one. This one, notice a product going on here, e to the x times ln x. So you have to use product rule. Derivative of e to the x is e to the x. Natural log stays the same. Plus derivative of natural log is u prime over u. U prime is 1, right? Derivative of x is 1. U is x times e to the x. And that's about as simple as that one's going to get, so just leave it like that. This one, again, u prime over u. U prime is 4x to the third. U is x to the fourth. If you simplify, you're going to get 4 over x, right? 3x's cancel on the bottom, and you get this. This one, natural log 2x squared. This is going to be a quotient rule problem. Derivative of the top is u prime over u. Derivative of 2x squared is 4x over 2x squared times sine minus derivative of sine is cosine times this all over, oops, not over the y, all over sine 3x. Let's just clean it up a little bit. This is going to simplify to 2 sine 3x over x, right? The 4x over 2x squared simplifies to 2 over x minus cosine, I think I forgot a 3 up here, cosine 3x, this should be times 3 up here. So 3 cosine 3x times natural log 2x squared. And this is all over sine 3x, my goodness, quantity squared, the whole thing squared. And let's just leave it like that, that's enough. That was a big one. So J is a product rule 1, derivative of u and v, right? So u prime is cosine 3x times 3, v is cosine 4x, plus derivative of cosine is negative sine 4x times 4 times sine 3x. Simplify this, you're going to get y prime equals 3. You cannot combine this to make cosine squared because they're different ones. So 3 different insides, cosine 3x, cosine 4x plus, no, minus now, minus sine 4x sine 4 sine 4x 4 sine times sine 3x. Right, so that's this one. And then the Darth Vader helmet, life will be easier if you write it like this. And the reason it's called the Darth Vader helmet is if you actually graph it, you'll see what it looks like. The derivative of that is, we're using chain rule, bring down the 1/3, 2 minus x squared to the negative 2/3 times the derivative of the inside is negative 2x. So we're going to get y prime equals negative 2x over 3. And then this whole thing is going to come to the bottom and become 2 to the 2/3 power. And lastly, just to practice writing as a radical, we're going to write cube root 2 minus x squared all squared, right? And that's your best answer for Darth Vader's helmet derivative. And then, go through and check them all on your calculator, see if you get them. All right, hope these are helpful.